Hello, welcome to another foundation class with Mathema. My name is Mr. Legend and I'm your tutor. Today we'll be discussing another important foundation topic in mathematics called LCM, and in full, lowest common multiple. Sometimes it is referred to as the least common multiple. And before we go into checking out some examples, I need you to have your mind refreshed on prime number, because you will need the knowledge of prime number for you to do this LCM calculation seamlessly. What is a prime number? A prime number is a number divisible by 1 and itself only. For example, the first prime number that we have is 2. 2 can only be divided by 2 and 1 only. That is, by 1 and itself only. 3 can only be divided by 1 and itself only. 5 can only be divided by 1 and itself only. 7, 11, 13, 17, 19, 23, and so on and so forth. So you need to have your mind refreshed on prime numbers, because you will be needing the knowledge of prime numbers for you to do the calculation on LCM correctly and smoothly. So, in brief, what is LCM of numbers? For example, here in the example 1, find the LCM of 8 and 16. What will be the LCM of 8 and 16? According to the full name of LCM, the LCM of 8 and 16 is that lowest number, least number, smallest number that can be divided by 8 and 16. And such number must be positive. It must be a positive number. As you can see, 8 is positive and 16 is also positive. So the number that will be the LCM of 8 and 16 will be the smallest positive number, lowest positive number, the least positive number that can be divided by 8 and 16. Please pay attention to the word smallest. So let's get into the calculation. For the number 1, I have 8 and 16, and we use tabular form to find the LCM easily. Although there are other ways you can write the factors out and get to LCM, but I will advise you to use this method because I believe you will find it easier. So we have 8 and 16, and then you draw something like this. Okay, the first thing we need to think of is a prime number that we can use to divide 8 or 16. Any of them, that prime number that we can use to divide 8 and 16. And then the knowledge of your prime number should come to your mind right now. And you are advised to always start with from the smallest prime numbers, and then you go higher. That is in ascending order. Use your prime numbers in ascending order from 2 to 3 to 5 to 7 to 11 and so on and so forth, depending on the numbers you have here. So if I'm to go by these prime numbers here, I know that 2 can be used to divide 8 and 16. So I will put my 2 here. 2 in 8 will give me 4. 2 in 16 will give me 8. Okay, the numbers I have now is 4 and 8. I will also check again which prime number can still be used to divide 4 and 8 here. I know I can still use 2, so I will repeat 2 again. So I have 2 in 4, 2, 2 in 8, 4. Now I have 2 and 4. Which prime number again can I use to divide 2 and 4? It is still 2, so I have to repeat 2 again. And then I have 2 in 2, 1, 2 in 4, 2. I'll look at it again. Now I have 1, I have what? 2. Of course, if I have 1 here, definitely I know that 1 divided by 1 will still give me what? 1. So I don't need to use 1. But because of the 2 I have here, it means that I can still use what? 2 to divide. So 2 in 1, because 2 cannot go in 1, so I will bring down my 1, and my 2 in 2 will give me 1. In LCM, once you have divided and the last numbers you have are in ones, so you know that you have gotten to the end of the what? Calculations. So the next thing you need to do is to write, therefore, LCM of 8 and 16 equals the numbers, the multiplication of the numbers you have here, 2 times 2 times 2 times 2, 1, 2, 3, 4, 1, 2, 3, 4, and 2 times 2, 4 times 2, 8 times 2, 16. Therefore, the LCM of 8 and 16 is 16. 16 is the smallest number that can be divided by 8 and also that can be divided by 16. Of course, you know, we have several numbers that can be divided by 8 and at the same time by 16. But 16 is the smallest, is the least, is the lowest number that can be divided by 8 and 16. So we say 16 is the word LCM. Let's try the next example. That's example 2. Let's try example 2. In example 2, I have 9 and 12. Example 2, I have 9 and 12. So I'll put my 9, I'll put my 12. So I'll check which prime number can I use here. I know that what? Although 2 cannot go in 9, but it can go in what? 12. When I say 2 cannot go in 9, I mean that 2 cannot go in 9 without remainder. So I must deal with number that I will divide by any prime number I'm choosing and that will not give me any remainder. So I'm choosing 2 first because 2 can still deal with 12. 2 in 9, because there will be remainder, so I will bring down my 9 because 2 cannot go accurately in 9. But I will go on to my 12. 2 in 12 will give me 6. I have 9 and 6 left. Okay, which prime number again can I use to divide? Here, I still see that 2 can still be relevant. I've told you that be careful with the usage of your prime numbers. Make sure that you exhaust the use of 2 before you move down to 3, before you move down to 5. And I can see that although in no order, if you still do it otherwise, if you do it correctly, you will still get correct answer. But as a beginner, it's good that you follow this. You exhaust the use of 2 first before you move to 3 and then the next. So I can still use 2 because 2 can divide what? 6 here. I will say I'll still bring down my 9 because 2 in 9 will give me remainder. Anyone that will give me remainder, I will bring down the number again. But 2 in 6 will give me 3. 2 cannot go in 9 accurately and it cannot go in 3 accurately. So it means that what? I've exhausted what? The use of 2. Then I will move to 3. Can I use 3? Can 3 go in 9? Oh yes, 3 can go in 9 and can also go in 3. Very good. So I can say that what? 3 in 9 will give me 3. 3 in 3 will give me 1. I've gotten 1 here, so I do not have any problem. I've told you once you get 1, you have come to the end. But when you look at this 3, 3 is still here. So what number can I use? I can use 3 to divide 3. So I will still bring what? 3 here. 3 in 3, 1. 3 in 1, because 3 cannot go in 1, I will bring 1 back. Just like the same way I said 2 cannot go in 9 accurately, I bring down 9. So 3 in 1 also, just bring down your 1. And 3 in 3 will give me what? 1. And then when you have what? In ones like this, you know that what? You have come to the end. You write out your LCM and that's what remains. Therefore, LCM of 9 and 12 equals 2 times 2 times 3 times 3. 2 times 2, 4 times 3, 12. 12 times 3 will give me 36. Therefore, the LCM of 9 and 12 is 36. 36 is the least number or the lowest number or the smallest number that can be divided by 9 and 12. So, let's try number 3 now. Number 3. Number 3 question. Now, in number 3, we have 3 numbers together. That's to show you that you may have more than 2 numbers. Okay? You can always find your LCM. It's the same process. So I have 8, I have 9, I have 10. Now we can move faster. The first one I use is 2, 4, 9, 5. Then 2 again, because 2 can still go in 4. Say 2, 9, 5. Because 2 cannot go accurately in 5, cannot go accurately in 9. So I'll bring the number down. So I have 2 again, because 2 can go in these 2 yet. I have 2 again. 2 here, 1. 2 in 9, still bring down my 9 and my 5. Okay, I've exhausted the use of 2. Now I think I can use my 3, because 3 can go in 9. So I have what? 3 in 1, bring down 1. 3 in 9, 3. 3 in 5, I bring down 5, because 3 cannot go accurately in 5. I have 1, 3, 5. I can still use 3 because of this 3. 1, 1, 5. Now it remains only 5. 5. Then I have 1, 1, 1. Now I can write out my LCM of 8, 9, and 10 equals 2 times 2 times 2 times 3 times 3 times 5. Okay, now I can say 2 times 2, 4, times 2, 8, times 3, 24, times 3, I can say that is 72. Then times 5, so I have 9, I have 4, 36, that's 360. 360. Okay, so the LCM of 8, 9, and 10 is 360. That is, 360 is that number, the smallest number, the least number, the lowest number that can be divided by 8, 9, and 10. Okay, let's try number 4. You can always use your calculator if you get here, if at your level is allowed. But if it's not allowed, just go by your multiplication. 2 times 2, 4, times 2, 8, times 3, 24, times 3, 72, and then times what? 72 times 5, 72 times 5, that's what I did. I can say 0, 1, that's 36. So you get your 360. It's just as fast as that. So I can proceed to number 4. LCM. Number 4 example. Number 4, I also have 3 numbers there and 15. So I can say that I have let me write it out in tabular form. Okay, I have this in tabular form. And what's the first number? If you observe very well, you can see that 2 cannot go in any of them, but 3 can do something there for me. In 25, 3 cannot go accurately because it will remain 1. So I have to bring down my 25. 3 in 3, 1. In 15, 5. And if you observe again, 3 cannot go again. So when I proceed to 5, I find out that 5 can go here, 5 can go here. So I will use 5. Okay, 5 in 25, 5, 1, and 5 in 5, 1. 5 again can go, I will have 1, 1, 1. So I've come to the end. I can say, therefore, LCM of 25, 3, and 15 equals 3 times 5 times 5, and that will give me 75. 3 times 5, 15, and 15 times 5 will give me 75. 75 is such the least number, lowest number, or smallest number that can be divided by 25, 3, and 15. And this is how easy LCM is. I want you to go through the class over and over again and then try to attempt the assessment I will drop in the comment section. Lay your hands on it, give it a try, and let me know how easy you find the questions in the comment section. You can share this class with fellow students like you or students around you, and even people that you think that they have gone higher than this level in mathematics. Let them have their knowledge refreshed, and let everyone get to do well in the foundational knowledge of mathematics. Share this video out, subscribe to our channel, and do turn on the notification button so that you can get informed anytime I drop a new video. My name is Mr. Legend and I'm your tutor. I'm committed to helping you in getting that excellent result that you so desire in mathematics. Bye for now.